In this video, we look at the relationship between force, gravity, and mass. So the idea that if you weigh 100 pounds, which is an American way of doing weight, on Earth, you'd weigh only 17 pounds on the Moon, 38 pounds on Mercury, a similar 91 pounds on Venus, only a little bit lighter, 38 pounds on Mars, which is the same as you see as Mercury. You'd weigh 253 pounds on Jupiter, 107, so not too different to us, pounds on Saturn, 91, again similar on Uranus, and 114, so similar-ish on Neptune. So why is that, and how do we work this out? So gravity is the it's the attraction of two objects based on how much mass they each have. So if an object has a lot of stuff that makes it up, it will pull against other objects with quite a high force per unit mass. If an object is quite small, then other things of bigger mass will pull on it stronger than it pulls on them. It's why we're able to stand on a sphere, which is the Earth, and not fall off. We know that in order for an object to move, it needs to be acted on by a force to make it move. So this down right here, gravity is attracting them to the Earth as a whole. Similar here, similar here, similar here. There's no reason for this person to fall off because there is no force pulling them up. There is only a force pulling them in towards the Earth. Interestingly, the force of gravity, this attractive force on Earth, is 9.75 at the surface of the Earth. If you go out 4,000 miles, which is 6,432 kilometers, you only have a force of 2.44. If you go out twice that, it becomes 1.09. If you go out another 4,000, it becomes 0.61, and then further and further and further. If you get 24,000 miles away, which is, I think, more than the diameter of the, what am I talking about? Yeah, the circumference of the Earth, it's down to 0.18. So that attraction is a lot less than if you're standing on the surface of the Earth. The force of gravity is a constant force. People always get gravity and speed mixed up, so they assume that an object that we'll talk about it in later parts of this video, but objects which have a higher mass have a higher force pulling them towards the ground. Now that is true, but that is the force, that is not the same as the speed. So interestingly, if you Google hydraulic press crushes stuff, you will see these things that look like this. So there is a fixed metal pad here, and there's a metal pad here that slowly drops down. And the cool thing about it is it doesn't suddenly accelerate down towards this, stop, push, and then crunch. There is enough force in this object that it slowly glides down, 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 till it touches the bottom. Before it touches the object that it's crushing and after it touches the object it's crushing, there is no difference in its speed. The force it is applying is enough to crush that, whether it's crushing a big metal vise or it's crushing this little Lego person. The force applied is enough to just glide straight through. The speed never changes. So it's a high force but a low speed. So we'll talk about that in a second. So the way we work this out is the force with which something is pulled towards the center of the Earth, on Earth, is its mass multiplied by the gravity on our planet. So our gravity on our planet, as we said here, is 9.75. For simplicity, we will change it between different questions. So if you are standing on Earth and your mass is 10 kilograms, gravity will pull down, in this example, with 10 gravities. Doesn't really matter the unit. So the force with which that object of 10 kilograms is pulled towards the Earth is its mass, which is 10 kilograms, multiplied by gravity. So that object, when it's on Earth, is pulling down with 100 newtons of force. So it's the force which is 10 multiplied by gravity, which is 100 newtons of force. If we have the next question, so the force is what? We've got a mass and we've got gravity here. So how will we go? Pause the video for question 1 and question 2 and see if you can work out what the force is. If force is mass times gravity. Okay, so for this first one here, the force is 20 multiplied by 2, so the force will be 40 newtons. For this one, force is mass multiplied by gravity, so it's 5 multiplied by 0.5, which is 2.5. Okay, so we've put it in kilograms here because that's the unit it has to be in. If that was given in grams, it would be 500 grams. So if the question said force question mark mass 500 grams, gravity 5, we would have to convert this into kilograms first. Questions 3, 4, and 5. Pause the video and have a go. Okay, again, so this time we've got it slightly differently. So the force is given to us, but we don't know the gravity. So we actually have to move the bits around in this equation. So force is mass times gravity. So 10 is 5 times what? So you might know 5 times 2 is 10. Now the way you would do that is you would you basically divide both sides. You might have done this in maths, you might not have. You divide both sides by 5. So it's 10 divided by 5 equals whatever this is, and it gives you 2. The way to do this easily is force is mass times gravity is the same equation as gravity equals force divided by mass, or mass equals force divided by gravity. So we've got a triangle here that we can use, so you cover over whatever you want to find out. If you want to find out mass, it's force and then divided by line gravity. If you want to find gravity, force divided by line mass. And if you want to find force, it's mass times gravity. Okay, so you can use this triangle here, this pyramid, to work it out. So for this one here, we have force, mass, gravity. You want to find gravity, so you cover gravity, so it would be force divided by mass. So 5 divided by 0.5 gives you 10. Similarly, in question 5, we need to find mass, so you cover that over force divided by gravity. You'll notice in question 4, we were given the 500 grams. We talked previously about the fact that if you're given 500 grams that you are here, you have to convert it into kilograms. So here we are. We've got 5 divided by 0.5 gives you 10. And here we're trying to find mass. So it's force, so it's 1 divided by gravity, which is 9.7. So you actually end up with 0.1 kilograms, which is 100 grams. So hopefully that made sense. You can watch the video again and it will go through the worked examples. This pyramid is a really good one to remember. Have a go at the questions and have a go at the research task.